quality of service, QoS. You've probably heard the term thrown around in networking conversations, maybe seen it pop up in router settings, or read about it in some tech article. But what actually is it? Here's a simple way to think about it. Picture this. You're trying to get to work during rush hour. The roads are packed, cars everywhere, bumper to bumper, you're stuck. Now imagine if emergency vehicles, ambulances, fire trucks also had to sit in that same traffic. That would be a disaster, right? They have urgent jobs to do. So we give them priority. They get special lanes, sirens, the whole deal. They get to move while everyone else waits. That's basically what quality of service does for your network. When your network gets congested, when too much data is trying to squeeze through the same connection at once, QoS decides which data gets priority. It's traffic management for the digital world. Let's break this down properly. Networks, just like roads, have limits. You've got a connection between 2 points, maybe your office and a branch location or your home and the internet. That connection can only carry so much data at once. There's a physical limit. When you hit that limit, congestion happens. Packets start queuing up, waiting their turn. Some might get delayed. Some might get dropped entirely. Your video call starts freezing. Your music starts buffering. Your downloads slow to a crawl. Without QoS, your network doesn't care what kind of data is moving through it. It's all the same. First come, first served. A video call packet has no more importance than someone downloading a random file in the background. The network just pushes data through in the order it arrives. No logic, no priorities, everything gets treated equally, which sounds fair but isn't actually smart. Because here's the thing, not all traffic is equal. A video conference call needs consistent, uninterrupted data flow. If packets arrive late or out of order, your call glitches. People freeze mid-sentence. Audio cuts out. It's annoying and sometimes critical if it's an important meeting. But an email can wait a few extra milliseconds. Nobody's going to notice if it arrives half a second later. Same with file downloads. They can handle delays without anyone really caring. QoS recognizes these differences. It lets you tag certain types of traffic as more important than others. You can tell your network, hey, voice and video are priority number 1. Make sure they get through smoothly. If something has to wait, let it be that software update running in the background. So how does this actually work? It starts with categorization. You sort your network traffic into different groups based on what it is. One common setup might look like this. You create a category for real-time traffic, which includes things like voice calls and video conferencing. These are sensitive. They need consistent bandwidth and low delay. Then maybe you create another category for network management stuff, routing updates, system monitoring, things that keep the network itself running. Another category could be business-critical applications, your CRM, your email server, important web services, and finally, you'd have a category for everything else, non-essential browsing, personal streaming, downloads. Once you've got your categories, QoS applies different rules to each one. For that real-time traffic, you might reserve a chunk of your bandwidth just for them. Even when the network gets busy, that bandwidth stays available for voice and video. You might also configure your router to process those packets first, ahead of everything else in the queue. For less urgent traffic, you can use something called shaping. Shaping basically holds back certain packets, buffering them until there's bandwidth available. It smooths out the flow. Instead of letting non-essential traffic flood the connection all at once, it spreads it out over time. This prevents those big spikes that cause congestion in the first place. There's also something called policing, which is a bit more aggressive. With policing, you actually set a hard limit on how much bandwidth certain applications can use. If they try to exceed that limit, their packets get dropped. It's like saying, you get this much and no more. Now, understanding QoS also means understanding the factors that affect how data moves through your network. There are a few key parameters here. First, bandwidth. This is the big one. Bandwidth is basically the capacity of your connection. How much data can flow through it at once. Think of it like a water pipe. A bigger pipe lets more water through. A bigger bandwidth lets more data through. Simple. If you want good quality of service, you need adequate bandwidth. You can't get around that. Then there's delay. Delay comes in different forms. There's propagation delay, which is the time it takes for a signal to physically travel from point A to point B. The farther apart those points are, the longer this takes. Can't really change the laws of physics here. There's transmission delay, which is how long it takes to actually push a packet of data onto the connection. Bigger packets take longer to transmit. Higher bandwidth connections transmit faster. And then there's queuing delay, which is often the biggest culprit. This is the time a packet spends waiting in line at routers and switches along its path. If there's a lot of traffic ahead of it, it waits. If the network is congested, queues build up. packets sit there, and waiting means delay. QoS directly tackles this by managing those queues intelligently, making sure the important stuff doesn't get stuck behind less important stuff. There's also jitter, which is variation in delay. Imagine packets from the same video call arriving at inconsistent intervals, some fast, some slow. That inconsistency causes problems. Real-time applications hate jitter. QoS helps smooth that out. And finally, packet loss. When a network is overloaded, packets get dropped. They just disappear. Some applications can handle this okay, they'll just resend. But for real-time stuff like voice or video, packet loss is brutal. You lose chunks of conversation. Video pixelates. QoS reduces packet loss for priority traffic by making sure it gets through even when the network is slammed. So that's the basic idea. Quality of service is about managing limited network resources intelligently. It's about making sure the traffic that matters most gets the best treatment. But here's something crucial you need to understand. QoS is not magic. It doesn't make your connection faster. It doesn't add bandwidth. It doesn't eliminate congestion. What it does is manage congestion when it happens. It makes the best use of what you've got by prioritizing intelligently. If your network is constantly congested, if you're always hitting capacity, QoS is a band-aid, not a cure. You probably need a bigger connection. You need to upgrade your bandwidth, or you need to rethink what traffic you're allowing on your network in the first place. QoS helps you squeeze better performance out of your existing setup, but it's not a replacement for adequate capacity. Think of it this way. QoS is like a really good traffic cop. They can direct traffic efficiently, keep things moving as smoothly as possible, make sure emergency vehicles get through, but if the road itself is too small for the volume of cars, even the best traffic cop can't fix that. You need more lanes. So when should you use QoS? When you've got a connection that occasionally gets congested, or when you want to make sure certain applications always get priority even when things get busy. It's especially useful for real-time communications, VoIP, video conferencing, live streaming. These are the applications that suffer most from congestion and benefit most from prioritization. Understanding QoS gives